Same stone. It's doing blobs now. When I hold it, it's moving around a little bit. Things become more random. And the more random that they become, the more those lines become apparent. It's when I hold the darn thing still up against the lights like this, then it turns into blobs. The universe loves random. It is run by the Heisenberg uncertainty principle rather than a benevolent God, unfortunately. And it doesn't care one way or the other about us. It's just random chance and a favorable configuration for life as we know it in this universe. Those are the properties of the 92 elements that we have around us. Everything that we see is based on those 92 elements. They form in stars. Stars form everything all the way up to iron, all the time. The sun up there heating our atmosphere and giving us our food and energy is busily turning hydrogen into helium and helium into lithium and carbon, and that into iron. And it's called the iron cycle in nuclear physics, and that's where those elements come from, and they're much more abundant than the elements beyond that. And that limit is built into the way that nuclear fusion happens. And the biggest of stars, even the big blue ones, are not, they don't create enough gravity or the inward pull to squeeze things together that much. It only happens when those big blue ones go supernova, and then that creates enough pressure in that shock wave to create the other elements up from iron. So what we have here is a carbon atom, a molecule, and the carbon is all joined together in a double covalent bond. So they're locked into place. And some among them are carbon-14. And a given percentage comes with all populations of carbon. Now, I read in Wikipedia yesterday that they think it's from cosmic rays hitting the carbon on the surface of the Earth. Well, that wouldn't account for all the carbon-14 in these diamond crystals that come from deep in the Earth, down near the molten mantle. And that, in fact, is where it comes from. The carbon-14 is part of all carbon. all carbon, because as the sun makes it, or a sun, it wasn't our sun that made it, it came from some other sun, in dust, right? Stardust, in nebula, turn into stars, and they start fusing hydrogen into helium, helium into lithium and carbon and iron and stuff, all the other elements in there. And there's a certain percentage of each in that panoply of elements because of the fusion cycle within the sun. It has nothing to do with cosmic rays, man. Cosmic rays have a hard time reaching the Earth because we have this electromagnetic field around the Earth that takes charged particles from the sun and directs them around us so that they don't hit us. Otherwise, there wouldn't be any life on planet Earth. It's a very necessary part of our existence, and that is that protection from cosmic rays of any sort. All of the charged particles that I have are electrons, and I'm creating electrons there with my rock. The carbon-14 is trying to become carbon-13. It wants to get rid of the mass of a proton, and it's giving it off one electron at a time. There's an 80,000 times difference in mass between an electron and a proton, and so it has to give off a lot of electrons before it loses enough mass to become a proton, in which case it turns carbon into nitrogen. Wow, huh? That's pretty amazing. And so it's giving off electrons like mad, but it's distributed across all the carbon-14 atoms that are inside that population of carbon atoms in that particular molecule. And it will continue giving off. See, because they're donating their electrons too. And they share their electrons in a double covalent bond. And that's what it means. It means they share those electrons with each other. And that's what makes carbon so very, very hard and very, very dense and very, very clear. And it's also what makes it give off these colors like this, because those are electrons being zooped at you at light speed, coming off of that rock right there, or the rocks on people's fingers. Same ones, same thing, only different. And then when the sunlight hits them, they do give off electrons, and they're not dangerous at all, I don't think. I mean, television sets do the same thing, and people sat in front of those kind of things for a long time before we came up with light-emitting diodes, and light-emitting diodes are what is underneath of that laser thing right there. That's the laser turntable has 7 of them. 1 in the middle, 6 around the outside. And it's kind of a fractal of the carbon atom. Interesting. And here we have a carbon molecule giving off a very orderly pattern. Look at that. It's right at the cusp of order and disorder. Order and chaos. And that is what fractals are. That's how fractals come about. Fractals are self-similar shapes at all scales. Magic light. I think it's magic.